Today I'd like to share with you a unit I designed on chemical amounts. This unit focuses on introductory information like moles, molar mass, percent composition, and empirical formulas, which are important for future lessons on stoichiometry and acid-base titrations. There aren't any next-generation science standards specific to this chemical amounts unit. However, several standards are very closely related, specifically those focused on mathematical representations of atoms and dimensional analysis. The chemical amounts unit was designed to be self-paced. To accomplish this, I created a variety of different materials. The first resource that I'd like to share is a video that introduces students to Avogadro's number. I begin the video by using terms that the student is already familiar with to demonstrate simple dimensional analysis. Here's a short clip of this video.
Well, we can tackle this problem by going back to our friend, the fence post, because this is a conversion type of problem. So just a reminder of our steps to completing a conversion problem. First, I want to identify the path. In this case, I'm converting dozens of donuts into individual donuts. Our second step is to build the fence post by putting that path across the top. Then, we drag our units diagonally, so dozens moves to the bottom. Next, we fill in each box with numbers using conversion factors where appropriate. So here, I would put 3 dozen, my starting number, in the first box, and then my relationship, which is 12 dozen donuts, is 1 dozen, our conversion factor inside the fence. Finally, we'll solve by multiplying across the top, 3 times 12, multiplying across the bottom, 1, and dividing the top by the bottom. So if I had to purchase 3 dozen donuts, I would need to purchase 36 donuts.
After showing the students a simple dimensional analysis problem, I can then introduce the same style of question using chemistry vocabulary. This particular video was created using PowerPoint and Camtasia. For my current freelance work, I use a proprietary app on an iPad where I hand draw all of my own visuals and add voiceover. The next resource I want to show is a lab. In this lab, I provide background information on a real-world problem: increased chloride concentration due to water runoff. A simple procedure is given, and the students are asked to create their own purpose and data table. The post-lab questions walk the students through the different calculations necessary to determine concentration, a concept that has not yet been taught. They can then compare their concentration to real-world values and make a conclusion about their sample. The next resource is a reading. This document was created to supplement what is often a very small section in the textbook. The language is simplified and the concepts are broken down into smaller components. To demonstrate the empirical formula calculation, background information is supplied, each step of the calculation is shown individually, and a flowchart is provided to summarize the steps. The section ends with a try-it-yourself problem. This is repeated for the section on molecular formulas, background information, sample calculations, flowchart, and test-yourself question. Towards the end of the unit, I like to give the students a challenge problem. A challenge problem usually involves real-world applications and incorporates information that the students learned in multiple units. In this challenge problem, students need to recall how to write chemical formulas, how to write and balance chemical equations, what a percent composition is, and how to perform dimensional analysis in order to calculate the cost associated with running a coal power plant. Lastly, we have the unit exam. The exam begins with recall questions, then moves into simple one-step calculations, followed by multi-step calculation questions on mole conversions, percent composition, and empirical and molecular formulas. I then include a question related to the lab experiments, asking students to determine an appropriate experiment for determining an empirical formula of a hydrate. The last question provides a sample student's response to a problem and asks the students to find the errors that were made. Many other activities were created for this particular unit, but hopefully this demonstrates the different types of materials that I can create.